Now, it's been a while since my last post on Trade Algo, and I decided to. I got kind of tired with trend following and flat strategies, and starting to look into arbitrage strategies. I've actually been looking into them quite a little bit before, but it's just about time now to put some stuff out on Trade Algo about it. So in this video, I'm gonna go out and show you guys how to easily calculate a correlation coefficient for any instruments and any time frame in Wealth Lab. It's done very easily. So basically, after today, with the code I'm going to give you, which you can download on my website if you're watching this on YouTube, you can just download the code. It's absolutely free, and just stick it into Wealth Lab, and all you have to do is just input the symbol that you want to measure the correlation. Okay, so I'm just gonna run through the code and run through the formula and run through some quick concepts so you guys understand how this works. And basically, that's all I'm gonna do. Right? So here's the formula. Think it was somewhere here. Just let me show you the formula. This is the formula, right? So basically, what it talks about. You can also check out some correlation videos on YouTube. Maybe I'll just stick in some other links for that. But basically, it's very easy. So there are two. We're going to talk in terms of data series in the Wealth Lab, right? So for example, there are two data series. Let me just open up somewhere where I can draw. Okay, so here's data series X, Y. So that's just a list of data series. Is just a list of values, right? And we're going to be, just so we're close to stocks, we're going to talk about close prices. All right, so let's say close X closes at, I don't know, $1, close Y, stock Y also closes $1, and they're just absolutely correlated 100%, right? So 1, 2, 3, and so on. Okay, now so what does this mean? So n is the number of values, right? So n here is equal to, I'm going to work with two values so it's easier. N equals 2 right now. Now this sign is for sum. So this is sum xy, right? So xy is x times y. So right here is 1. Now right here is 4. Okay, and so now sum xy is going to be 1 plus 4, and is going to be 5. Okay, now let's look further. Now we're going to need the sum of x, and sum of x is 3, and sum of y is also 3. Right, and now we're going to look at the sum of x squared, and right here we're going to put x squared, and that's going to be 1, that's going to be 4. So the sum of x squared, I'm sorry about the handwriting, I'm just writing with my mouse. So the sum of these guys is going to be 5, right? And we're also going to need the sum of y squared, which is going to be also, so y squared is going to be 1, 4, 1 squared, 2 squared, yeah, it's going to be the same as sum of x squared. Okay, so that's how the formula goes. And now, so just to find the correlation of these two guys here, all we got to do is n times n, which is 2, times xy, sum of xy, and sum of xy is 5, and minus sum of x, which is sum of x, it's this one, is 3, times the sum of y, which is also 3. Yeah, so on the top we have 10 minus 9, so this is 10, this is 9, and this is going to be 1, right? And on the bottom we have the square root right? And it's n times x sum of x squared. So first, let's just do n times sum of x squared. Sum of x squared is 5. 2 times 5 is 10. And minus the sum of x squared. Sum of x is 3, squared is 9. Okay, so this is going to be equal to 1. And obviously the other side is going to be the same. Right, so it's going to be 1 times 1, and the square root of 1 is 1. So the correlation coefficient for this is going to be 1. Okay, so now what does that mean? So we're looking for stocks usually that are really correlated. Yeah, and if it's 1, that means they're just doing exact same thing. So this is 1, right? So one goes up and the other one goes up by the same amount, right? So that's 1. And if we were to look for -1, then it would be something like this, right? So one goes down, the other one goes up, right? So this would be -1. And you can only get values between -1 and 1, right? Okay, so that's the math behind. It's very easy. Now the code. So I wrote a special method right here which returns the correlation coefficient, and you can do. I'm not gonna stick it in a separate DLL or anything, so it's easier for you guys to use. You can, you can. There's nothing else you can really do with it, but I guess you can, change the implementation a little bit by, well, I tried to make it universal, right? So what you gotta do, it returns double value, right? So first thing, you gotta use this method called getExternalSymbol. GetExternalSymbol is a wealth script method which returns an object of bars. And as we know, an object of bars consists of closed prices, consists of data series, right? Well, bunch of data series which low, close, volume, and such, right? So we get all the information for the symbol we want, right? I'm going to be doing an example on the Russian futures market, but you can do it with any time frame and any basically any market, whatever data series you have in Wealth Lab data set. I mean, you can do it with that easily. Okay, so what you gotta do is first thing you gotta get the bars for the other symbol. So because you are executing this the strategy, well, the correlation meter on a particular symbol, right? So first things first, you just have to, so for example, I'm executing at this point on a symbol called SBRF. So when I execute it, it's gonna go and into the symbol SI, which is this one, and get that symbol for me, get the bars for that symbol. And now right here I'm using it on one data series, but you can actually modify this, and I'll show you how. And there's also I think another method called actually it's right here. So there's getExternalSymbol, but there's also getExternalSymbol where you can actually specify the data set name as well. So it doesn't have to be on the same data set, but if you want to get the bars from another data set, just use the other return type for this method. It's also getExternalSymbol, but you can specify the data set name as well. All right. So getExternalSymbol, specify the symbol name that you're getting, and also specify true here, because the symbol which you're getting might not have the same data, right? What does that mean? It's very important. Now that means, for example, so here's your current symbol, right? I need to get a pen, seriously. Okay, it doesn't matter. So so for example, here's day 1, day 2, day 3, day 4, and the symbol has like close prices, right? And you get the other symbols bar, is that right? Yeah, so you get the other symbols bars, and they don't have day 2, for example. So they go like 1, 2, or day 3, and then day 4, right? But so when you click true here, when you set true here, it's gonna synchronize, right? So it's gonna, whatever you get for day 4 on the other symbol that you're getting, it's gonna synchronize it to date 4 on the current symbol, right? So it's gonna sync those two values. It's not gonna put it on day 3, so it's important you click through there. So now you have your bars synchronized, and here's the method, which is called correlation, and what you do, it receives data series, right? So you just need to send 2 data series, so it can be close prices against high prices, or high prices against volume, or volume against price, whatever you guys want. Any data series that you like, you can send into this method and you'll return a correlation value, right? So that's pretty cool. So it's very, very universal. And right here, so it returns a double R, which is the universal R always represents the correlation. Now I clear the debug window and then print out the correlation coefficient into the debug window. Okay. So, and here's the math which we just talked about in the previous section. Yeah. So R. So first I set them all to, I initialize the double values that I'll be working with, and then well, well, actually this should be renamed as to it's not really the sum, it's the multiple of, okay, multiple xy, right? Multiple xy. Okay, now it makes sense. Didn't change the math, just changed the name. Okay, so first I need to find out how many actual takes I have, right? And I'm so first, well, the thing is that you have to send the first value is the one that is the one you're on, right? The data series that you're on, the symbol that you're on, you send it first, because the number of takes that I'll be putting into the formula, the n value, so I'm talking about this n here, is always the number which we get it from the current symbol, the number of bars on the current symbol. Now, okay, so multiple xy, that's so here's the sum of xy, but first we need to get the multiple of xy, right? So that's if you remember the table which I erased, so that's when we were getting the xy value for every bar. Now this is the multiple of x data series, and this is the multiple of y data series. Now then I execute a little for cycle, because, well, data series doesn't implement any link methods that are there for lists and objects in C#, which is a big I think is a, well, it's a pity, but anyway, we have the for cycle, so I execute the for cycle, and here's our sum xy, right? So this is the sum xy, and that's how we get it. So we just we use the plus equal operator, which just adds up all the multiple xy values which we got up here. We do the same for the sum x and the sum y, and sum x squared and sum y squared. So exactly same stuff, right? So we add up all the values and we get the sum of xy, sum of x, sum of y, and sum of x squared and sum of y squared. Yeah, so that's where we get them all. And right here, well, just that, so it's a little bit more neat, I broke up the formula into 2 variables here, right? So this just the same stuff which we just talked about here, just in code. So n times sum of x squared minus sum of x times sum of x, which is I could use the math squared operator, I guess, but just doesn't really matter. Just multiply them 2 to get the squared value, and then I just stick the stuff into the formula and get r, right? So part 1 is n times sum x squared minus sum of x times sum of x, and this is the part 2 in this side. This is this part here, right? Which is n times sum of y squared, n times sum of y squared minus the sum of y squared. Yeah, so here's the sum of y, and then brackets. So, well, it doesn't really matter here, it's just minus sum of y squared. So we first find the y squared, and then we subtract that from from some y squared times n, right? I hope I'm making sense. Anyway, so and then the top part here, which is n times x times y, n times the sum of x times y, so n times sum of x times y minus sum of x times sum of y, yeah, all of that in brackets divided by, and then math square root of part 1 minus part 2. All right, and that's it, guys, really. So I take that, and so if I want to find the correlation coefficient, what I have to do is stick it in like that, compile. So I'm right now on this symbol and I want to correlate it to SI, and this SI, compile, run, and I'm on a daily time frame, and so what's my correlation coefficient is currently 0.2 for 3 years, right? And any time frame, really 5-minute time frame, let's see. So 0.20, same. Okay, go to, I don't know, let's correlate it to RTS. Is it actually, excuse me 1 second, 20494. Now if you want to check this, right, so instead of, if I put in the close price for this same two data series, it should give me 1. So here it returns 1. Okay, and so that's about it, right? So let's go check one more time. So I'm on BR. I'm right now on BR, and I want to check my coefficient of BR is the Brent, and I want to check that in SI, which is the Russian ruble, which is very, very correlated to the BR, should be. Let's see if that's true on the 5-minute time frame. And oh, sorry, I forget to change that here. So I'm just taking the close prices for those bars. Let's see what it gives us. So you see it's a negative 0.94, which is the correlation. So if basically if the Brent price for Brent goes up, the Russian ruble against the dollar the ruble becomes stronger, right? So that makes perfect sense. Okay, now let's see, we can change time frames. 0.94, I don't know, 60-minute. That's gonna be the same, I guess. Yeah, more or less. Okay, so that's about it for the correlation coefficient, and I hope you enjoyed it, and see you later.